Hey, folks, welcome back. Thank you so much for continuing to hang out with us today as we continue to celebrate the 10-year anniversary of Amazon Aurora. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, joined by my homie, Aditya. Say hey.
Hey folks, my name is Aditya Saman. I'm a principal database specialist solutions architect, and I get to work on Aurora every day, which is the star of our show. And we have two more stars today in our studio coming to you live, and they are going to talk about RAG. I have no idea what that means. Do you?
No idea. No idea. What is RAG?
Well, thank God we have our SMEs, Cheyenne and Jonathan. Why don't you guys introduce yourselves?
Sure. Thank you. So I'm Jonathan Katz. I'm a principal product manager on the analytics team, previously on the RDS team. I'm also on the core team of the open source Postgres project and have been involved contributing to pgvector, which is a core part of what we're going to talk about today with RAG.
Excellent. Cheyenne?
Hi, folks. Thanks for joining in. I'm Cheyenne. I'm a principal database specialist solutions architect here on the Amazon Aurora team. And yeah, we are going to talk a lot more about rags to riches.
Oh, wow.
Rags to riches. I like what you did there.
No slow clap.
No slow claps. Got to earn. Slow claps are earned, not given. Sorry.
Well, Jonathan, why don't you tell us more about RAG and pgvector and all that fun stuff?
Yeah. So, what we've seen in AI is that we have these very large models that have been trained. We call them foundation models, and they're trained on publicly available information. Now, a lot of information that makes it more useful to use them is in your private databases. Mm-hmm. So we need a way to be able to take that information, bring it to the foundation model that's cost effective and fast. And this is where RAG comes in, or retrieval augmented generation. Now, one of the most powerful aspects about RAG is that we can search over information that might not necessarily look like regular data, like numbers. We might search over text or images or videos. And we need a way to be able to take those text and images and videos and compare it to each other. Right. And this is where a vector comes in. Right. So imagine like I have this cup right here and I have this laptop. Like, what is more similar, like this cup to this cup or this cup to this laptop? And this is a thing called an embedding model, which is able to take this cup and transform it into a vector. And the idea is that the embedding model says like, hey, these two vectors that represent the cups are more similar to like this cup and this laptop. And that's the foundation of RAG, because then what happens is you perform the search with Amazon Aurora, and you can search over all your cups, using the vectors, and use that to send the information to the foundation model and get that very rich natural language response.
Wow, that is quite complicated. That sounds complicated.
Yeah,
I think Shine is going to make it uncomplicated for us.
I look forward to that.
I will. So if I'm allowed to just bring up my screen for a little bit.
Yeah, let's do that.
So, before we begin, 10-year anniversaries don't happen every day.
No.
This calls for a little bit of a confetti moment.
Yeah.
Confetti moment.
There we go. Confetti.
There we go.
All right. So, this is our AI-powered Aurora memory wall. And this actually brings together a lot of what Jonathan just talked about. So, what you look on your screen is a snapshot of the evolution of pretty much like a decade of innovation with Amazon Aurora. Right from 2015, which is where we began, which is where Aurora MySQL was actually generally available, all the way to fast forward 2 more years. This is where actually Postgres, the fully Postgres-compatible edition of Amazon Aurora, was born. And this actually led a key evolution, because at this point, we took 2 of the most popular open source engines and put it on a managed database platform. Mm-hmm. That was kind of a big deal back in 2017. Fast forward to 2022, this is where a lot of you in the audience actually told us, we don't want to deal with this provisioning capacity. We don't want to deal with this undifferentiated heavy lifting of managing servers anymore. So we took a step forward. We basically came up with a version 2 of our Aurora serverless database. Now, this was, again, a game changer. We had basically, you could now scale to hundreds of thousands of transactions in a fraction of a second.
Yeah, we actually saw a really cool demo on that David Vine was showing us earlier today.
Absolutely. In fact, if you're joining us now, if you just rewind and watch Dave's session, you are actually looking at the evolution of serverless, right? So that's a key technology evolution. Fast forward to 2025 is where we are now at the next evolution of serverless, which is truly distributed SQL serverless across the globe. This is Amazon Aurora DSQL, and we will actually have a lot more sessions, so please stay tuned.
So when you say distributed, does that abstract out, continue on that, the ongoing evolution of the decoupling of the compute layer and the storage layer, except you're doing that globally as a service for the customer so they don't have to go and build it and ask somebody like me to go and have to stand up an entire infrastructure every time that I need a new region or a new code deployment or a new anything. Is that about accurate?
It is. I think it is. But Adrian, I think you are stealing the thunder from some of the upcoming segments. So,
a little bit of a teaser there. So you'll probably want to
Cheyenne
hang out
is being very strategic and not giving anything away.
I'm not giving anything away.
I see that. You didn't fall for it.
Yeah, this segment is about using AI to do what you do.
Oh, I am a very good lazy admin. I would love to see AI do the things that I do.
Awesome.
I keep hearing that the RAGs are supposed to replace humans. Let's see if that's true.
We will see that. We'll find out by the end of this segment. All right. So if we want to pull back the curtain a little bit, let's actually see what's going on. So we have our Aurora Postgres database here, version 17.5. And we talked about a little bit about the vector data type, right? So again, within the Postgres ecosystem, extensions are a way to enable certain things, certain functionality, certain extended sort of capabilities. And a vector is one such capability. So we bring a specialized data structure, such as a vector that will store your vector embeddings. And we also bring some specialized, of course, it's a relational database, so we want to care about performance. So we bring specific indexes. And while I show you the table, Jonathan, what's an index?
Yeah, so when you store data in a table, what happens is that you store every single row in that table. But if you want to do a search over that, say like, hey, find me all the rows around the 10-year Aurora live stream, you normally have to search every single row. And if you have millions and billions of these, that will take a very long time. Like even with, globally distributed, infrastructure. But an index points to the very specific rows that you may filter by, and you're able to quickly look it up. Now, with vectors, we have to do something special, because vectors are actually very computationally intensive to process, which is a fancy way of saying that it takes a long time to do all those vector comparisons, particularly if you have millions and billions of them. So we do an approximate lookup with the vector search. And there's a special vector index that you see here. It's the HNSW in that little font, which does a very efficient approximate lookup while still returning the answers very quickly.
You know what else is also unique? The demo dance that we forgot to do.
Oh, I guess it's time to do the demo dance?
It is time to do the demo dance. Sometimes it's a shimmy, sometimes it's a little bit of a shuffle, but it does have to be done.
All right.
So next up, Jonathan talked about a little bit about the approximate neighbor search, right? What does that mean? So if let's say I'm a DBA, I don't really know what that means. I'm going to run a query.
Hey, be careful about what you say to DBAs, okay? They're my homies there.
I knew you were going to catch me on that. All right. So this is a simple query, but not really simple, right? There is a little bit of nuance here. There's a lot going on. This is a CTE, and to a typical DBA, this actually is a pretty complicated query.
Yes.
But still, if I'm a DBA, I still know the syntax. I know SQL. I know a little bit of how it works. But you'll notice, if I'm looking for a milestone that we launched for Aurora, let's say related to performance, and I don't really know what are the features. I am looking at the latency. I'm looking at the throughput, et cetera. And those could be 100x. Those could be 10x. Those could be 5x. I just don't know. My intention is to search for all features related to performance, but I want to do it via SQL. So this is a query that will actually do that. So I want to look for something like 100x, but I'm specifically specifying that I don't want anything related to performance. So this is an intention of my query, which the semantic search engine should understand and give me, in this case, top 10 results related to that 100x. Now you'll notice in the results, you'll see something like push parallel query, push down processing, 100x. There is Postgres 17 support with faster writes. Okay, could be related to performance. There is Aurora MySQL 3.10, parallel query execution. Okay. NVMe storage optimized reads with Aurora Postgres 8x query acceleration. So without actually looking at a specific performance milestone, I'm able to derive a lot of related like features in my milestones table. This is what similarity search or semantic search is at its core.
Yeah, it's all math.
It's all math, which I'm sucking at.
Don't we all? Don't we all?
Yes. But this is where the database makes it easy because you don't need to do the math. You just need to do create extension vector, and it does it for you.
Yeah, and we want to thank our Postgres community for that. I
Yes.
mean, this is all possible because of that. And I know you are a big part of that, Jonathan.
A little bit. One of my favorite projects I worked on was figuring out the costing model for HNSW and helping basically, which says when do you use the index versus when do you use the database, and that's all automated. That's a lot of fun.
He says little. All right, well, Cheyenne, let's continue with your demo.
Yes. So if you're dialing in now, we talked about a little bit about MCP, but if you're sort of just brand new to the concept, there's a lot of buzzwords these days in the agentic AI world. MCP is another such buzzword, but then it's becoming more and more real as we are progressing. So in this case, think of MCP as just another way, a standard way to communicate with your data sources. The AI applications will use a certain set of tools to connect to your databases, data sources, etc. So in this demo, we also have the MCP integration plugged in. And a couple of things that we've actually weaved into this is one of the core sort of innovations around the Postgres engine has been the Aurora Postgres MCP server. And we also have a bunch of other engine-related MCP servers. So if you go to the MCP portal, for example, and if you go to the website, you will notice that there's a whole bunch of MCP servers available here on the AWS portal, including an MCP server for DSQL, an MCP server for MySQL, as well as Postgres, which is what we are using today. So in this case, let's go back to our MCP config file. And here, what you basically specify is a Postgres as our MCP server. Out of the box, what we get with MCPs is a couple of tools, right? So here with Postgres, we have the run query tool, which will run a certain query on your database. Just think of it as a dumb query, like a select query, etc. And there's also a get table schema tool that's available, which will basically describe the table, describe the data structure of the table, etc. The other MCP server that we have also weaved into this demo, which is again, remember, our AI applications can hallucinate. So there is always a tendency for it to go and do its own thing.
Yeah.
It can go wild, it can just go run crazy, so you just don't have any control over it. So what we want to do as a best practice is to ground those responses that our, let's say, chatbot is giving us.
That's a very parental thing to say, that if you start hallucinating or acting up, you're going to get grounded. I appreciate that. Trust me. I really, really appreciate that.
Well, we want to hear from audience. What are your experiences with AI hallucinating? Let us know. We want to know.
And if it's funny, we might even do some credits or something.
Yeah.
But this is where MCP helps a lot because it's not just that it grounds the truth; it gives that additional context for how the agent searches over it. So you're basically telling the agent hey, these are your databases. This is where that information lives. Hey, this is the documentation where you can get that truth and not hallucinate and come up with
something else.
Yeah.
Exactly. So now let's actually look at an MCP query in action.
Okay.
So this is Kiro. Again, folks in the audience, if you haven't tried Kiro, do give it a try. It's easy to get started.
And I see it's very fresh. I see Kiro Public Preview. So
Yes.
you don't have a special edition.
I don't have any
everything
special editions
available
here.
out there. Yeah.
Yes. So this is where we have our MCP servers defined. If I just go here to my Kiro view, you'll notice my couple of MCP servers. This is basically coming from my MCP config file. And then if I just zoom in a little bit here, I'm going to ask a question. So check in natural language. Note that I don't want to deal with any more of those complicated SQL queries, CDEs. I don't have to have any knowledge of SQL. Now, but there's still a certain nuance to it where I am specifying pgvector. I am specifying semantic search. So there is a little bit of prompt magic that goes into this. So check if
I see that you cleverly avoided prompt engineering.
Yes. I hate engineering. Trust me, I was a dropout. Just kidding. Check if pgvector is installed in the Aurora milestones table. Find all the AI ML related launches that we've done, and then look up the documentation just to ground our responses. And what's an easy way to get started? So let me fire up this query. Hero's going to come up with a cute little emoji here. It's probably working on its own magic.
It's looking. Look at that. That's awesome.
And
Is that supposed to be like a ghost?
It is.
It is a ghost now.
Yeah, there's a whole backstory to that.
Is there?
Yeah.
Do we have time for that?
I don't know. Let's see if we get through the demo.
Okay.
Right.
So what it's doing in the backend is while it's doing a lot of the sort of inventory analysis, it's looking at my config files. Behind the scenes, the magic is it's actually automatically invoking the MCP tools that is at its disposal. And this is what we specify via the mcp.json config file. First, it's going to do the run query via the Aurora Postgres MCP server. It's going to check whether I have pgvector installed, etc. Go look at my milestones table, and then get proper documentation to ground those responses for the chat. So here, of course, it's going to nicely condense that response in a beautiful summary. But then you'll notice this is the power of natural language, right? This is the power of MCP servers. Again, a concept by Anthropic, kind of revolutionized the whole industry on how can we actually, with one standardized communication protocol, connect our AI applications across the world to different LLM models, to different agents, to different databases, data sources, etc.
Yeah, and I think that this is so powerful, the MCP protocol itself, because the standardization, as you can see, has brought us MCP servers for pretty much all of our AWS services in a very short while.
Yeah.
So that kind of shows that how strong that foundation is.
Absolutely.
Yep. And we see like the targeted responses you get from it are that much richer. Like when you can point an agent specifically to read the documentation, which we also need to point humans to read the documentation too. But we see like, if you look at that responses, like, hey, this seems like pretty right on in terms of all the things that we've launched for Aurora over the past decade.
Exactly.
All right. So MCP, again, is an awesome tool. It's an awesome introduction to the problem that we are trying to solve, again, is get a lot done with a lot less of the tribal knowledge for SQL, for example. But now we don't actually stop there, right? So typically, MCPs would be a great way to get started, great way to prototype, rapid acceleration on your POCs, etc. But then what we also are looking at is in production, it's not always a simple search, right? It's not always a semantic search. It's not a simple query lookup. There's more to it. And a classic example is if I'm on the Amazon website and I'm trying to search for, let's say, a black iPhone Pro Max 256 gigs versus get me an iPhone. There is a very strong difference in both of those queries, right? So there's this whole multi-step reasoning process that comes in. There is context awareness that comes in. There is this whole concept. In fact, Jonathan has led this in the industry called hybrid search with pgvector. There is a lot more that goes into re-ranking your traditional full-text search versus semantic search, and then kind of giving that end-user experience really solid responses back in that top page of the result. Maybe, Jonathan, you can speak about hybrid search a little bit.
Yeah. Well, hybrid search is, hybrid search can be viewed in a few ways. Most people view it as combining something like a vector search with a full text search, but effectively you're combining multiple search methods and placing certain weights on each one, and then doing that final re-ranking. And Postgres, maybe a secret about Postgres is that it does have a built-in full text search system and a full text search indexing. And even for the ones that are not built in, there's even more extensions around Postgres that help with that as well. But to the point, we actually also see this technique in the agentic world as well as we go through these searches, because we talked about RAG at the beginning, right? And retrieval augmented generation. And while that does help extend a single prompt that you send to a foundation model, there's more to it. You might need to take this in multiple steps. And this is where agents are such a powerful concept, because you can, they basically will repeatedly go through and keep seeking the answer until they can give that final output, such as the example that we saw in MCP. But there's still ways we can further prompt the agents and help the agents get even more specific answers to those domains.
Speaking of answers, we got a trivia question for you, chat. How does pgvector remember where it left its keys? I know you know the answer. I know you gentlemen know the answer. I am not a DBA, nor do I pretend to be one, but I can wreck a database pretty quickly. If you know the answer, drop it in the chat. We'd love to see it. And before we wrap, I promise we will give you that answer. So, okay. Jonathan, you made mention about how important it is to make the hybrid search available to folks. In your mind, how do you think we should be approaching the next evolution of building and iterating and starting to experiment?
Oof, that's the $64 question right there.
Well, I got about $32.50, so we're gonna have to make do.
Okay, so there's a few areas to start. That all these techniques we've talked about build upon themselves. They're iterative. So retrieval augmented generation was the hot topic 2 years ago. Agents are the hot topic today, but you can't have agents without RAG, or you can't have agents without RAG, so to speak, to keep with our pun of the day. But the idea is that all of this is iterative. You're still going to need a way to be able to take your source information, whether it's text or images or videos that you want to search over, and convert them into vectors that you need to be able to perform that search, and you need to store them in a database. So something like Amazon Aurora is still in place there. The big thing that's happening right now with agents is that it's so simple to deploy your own agents and have that, we call it an agentic loop, constantly, processing that information. But it all builds on itself. And as we're going to see from this next step of the demo, we're going to build this, this agent that's very aware of the decade of innovations across Aurora, and really bring home the concept that everything builds upon itself, even as we get into this agentic AI age.
I dig it. It makes a lot of sense.
Cool.
So, all right. So what Jonathan talked about is exactly what we are going to show next.
Excellent.
And folks in the audience, please do send in your experiences with agentic applications. If you're struggling, if you're on the happy path, do let us know. We'd love to get your feedback. So let's get into the next segment, which is extending that MCP concept a little bit further. Right, so remember, just to recap, MCP again is, you can think of it as a dumb query engine, which is literally just going in through these tools, is able to extract and glean certain insights, certain information from our database. But then that's where it actually stops. You need to extend in production sometimes cases like hybrid search, cases like extended thinking, cases like contextual awareness. There's a lot more that goes into a production application and a really nice search application at the heart. So this is where agents come in. This is also about autonomous decision making, etc. So on your screen, you'll see the Aurora Memory Wall AI agent, which is actually powered by AWS Strands SDK. Another buzzword. What is AWS Strands SDK?
Well, leave some questions for us.
All right. So, Jonathan, maybe you can guess.
So agents have these common patterns in them, and this is what Strands helps with. Is that Strands is an open source library that lets you build your own agents and assemble the common patterns to be able to point out either specific MCP servers that you need to use, or provide the necessary hints to be able to target exactly the information that your agent needs to search for. In this case, it might live within inside an Aurora database. But it makes it just so simple to build these customized agents. Like, it's so much fun to play with.
Yeah.
Absolutely. So speaking of a lot of fun, let's actually look at something in action here. Back to our memory wall.
Okay.
So we have an Aurora AI agent, which is powered by Strands SDK. We're going to start learning a few things about Aurora if you didn't already know it. So I'm going to ask a question: what are Aurora's latest innovations in performance, for example? And while we are bribing the cache gods for an
I
answer,
appreciate that.
we will actually go in the back end and start looking at what the agent is actually doing, right? So its thinking process. As a developer, I love to peel the onion. I love to look at what's going on behind the scenes. And this is what actually Strands also gives you, a great way to actually log your agentic workflow in your applications to look at what's the thinking process. Is there any debugging that I should put in? Is there any issues around latency, response time, etc.?
And wearing my security hat for a second, it's also like, what data is my agent accessing? And can I add audit trail? Because as agents get more autonomous in modifying the information, it's important to be able to log everything that they're doing.
Exactly. So here you'll notice that my agent again has, remember, the two basic tools. We still have the two basic tools, which is searching the Aurora milestones table and then searching the Aurora documentation to ground our responses. In this case, we'll see that the agent has actually gone in and looked at the tool number one, which is searching our database. It did a semantic search. It found some relevant results. It summarized it nicely. But then it also goes to the documentation and kind of summarizes again the features, which is more up to date. Again, LLMs in the traditional world are the problem. One of the problems also with LLMs is they are dated. They have a lot of stale information. So keeping it up to date, keeping it relevant has been a historical challenge with LLMs. In this case, we are actually going to the AWS docs, retrieving at real time the up-to-date application, and actually getting these nice little features here. And if you go back to our chat application, we see that Aurora has made significant strides in performance and scaling innovations. And we see a lot of these cool new features coming in. We also have our links to the documentation, etc., the user guide, the cross-database querying, etc., etc. So this is the power of agentic applications, which is where you are actually getting real-time information. The other thing is we also highlighted in our milestones in the Aurora memory wall. So you'll basically see a couple of these launches here highlighted. But that's the power of the agents. You are, again, with a very simple chat application in plain simple English, you are asking for a lot of data to pull together from a lot of different sources, etc., etc. It could be your database, it could be your documentation, it could be your APIs, it could be files, etc. But then we are always sort of up to date with our responses, and we are seeing like real-time sort of application development here with AI applications.
And how long did it take you to code this application, I wonder?
I did wipe code.
Of course you did.
I will be guilty on that. Sorry. So it took me just a week to get a full production application up and running.
And you know, the reason why I ask is I wasn't going to point out your wipe coding. I was just wondering, like, if you were to do this without MCP, how long it would have taken you? Like, I think that delta is quite big.
It would have taken me 6 months to like a year.
Yeah. Yep. Now, if I hadn't actually done any development, I would be like, I think you're making that up. But it is so true, right?
It is
like
so true.
The delta between doing wipe coding using MCPs is so huge compared to what you would do just manually.
Exactly.
And the amount of code to this, like if we go into it, it's really not all that much code either. That's what's really the powerful part. Like how much like strands encapsulates, how much like the MCP tooling encapsulates, that those interactions between us as mere humans and our AI agents.
Yeah.
AI friends or agents. All right, so we'll do one more fun one.
Okay.
And I love this question, the way the Strands is actually coming up with the response. Explain Aurora's entire 10-year journey using only emojis.
Ooh, that's a good one.
Yeah. Actually, I did a test earlier asking Q to explain to me MCP with only emojis, which it seemed like it was pretty right on, but I don't know how to describe an emoji in words.
Okay.
The trick was to ask our database elves nicely.
There we go.
So there we go. So you look at how Aurora was actually, from its early days, from a baby in 2014, all the way to a decade now. Fast forward, we are now a superhero. Isn't that fantastic?
Yeah, that is amazing. All 3 emojis. I know, by the way, you do owe our audiences some answers.
I do owe you an answer. The answer is, the quick refresher, the trivia question was, how does pgvector remember where it put its keys? And the answer is, it looks for things that are conceptually key-like. It may not be the exact same set of keys, but it's going to have the general idea of what a key looks like to try to do that matching. Is that about accurate?
Yep.
It's taken from the worst possible example of a database person. Well, thank you for making it simple enough for someone even just like me to be able to understand, contextualize, and really get a good understanding of the art of the possible that can be done with this technology. Gentlemen, thank you so much for coming through and hanging out with us today.
Absolutely a pleasure.
Thank you for having us. Yeah, it was wonderful.
Yeah, Aditya, what else do we have going on?
Well, I forget what our next segment is. Gary, can you remind me, please?
Yeah, absolutely. Coming up next, we've got a segment on how to spend $1 on Aurora DSQL, or trying to break $1. But before we get to that, we still have the survey. So please, chat, continue to iterate on that. Give us your feedback. Let us know what you like to see more of. And remember, the first 3,000 responses get a $20 AWS credit. But until then, just hang tight. We'll be right back with another session here in a little bit.